Multiply and divide monomials. Vocab. A monomial is a number, variable, or a product of a number and one or more variables. Here are some examples. X, 3a squared, b to the third, negative 2/7, and 6/10 d. These are all monomials. They are separated by commas, so you can see 4 individual examples. Vic number 1. Product of powers. To multiply powers with the same base, add their exponents. So here we have 3 to the second power times 3 to the fourth power. When we write this out in expanded form, we have 3 to the second power, that means there are 2 factors of 3, and 3 to the fourth power means there are 4 factors of 3. Total, you can see that there are 6 3's multiplied together, which is the same thing as 3 to the sixth power. Now there's a shortcut to this. If you use the Vic, when they have the same base and you're multiplying, you're going to add their exponents. So 3 to the second and times 3 to the fourth, you say 2 plus 4 gives you 6. And here it is in algebraic form. A to the m times a to the n equals a to the m plus n. You just take the exponents, add them together. Base stays the same. Simplify using laws of exponents. Example number 1. 5 to the second power times 5. Now you see this, the exponent is 2. Here, you don't see the exponent, but it's a 1. Okay, so if you don't see it, it's a 1. Now, multiplying, keep the base, so keep the 5, and add the exponents. 2 plus 1 gives you 3. So 5 to the third power is 5 times 5 times 5, which is 125. Example number 2. Same thing works if you have variables for your bases. C to the third power times c to the fifth power. Keep the base, which is c, and add the exponents. 3 plus 5 gives you 8. So c to the 8th power. Example number 3. I have negative 3x squared times 4x to the 5th power. You can group the coefficients. Coefficients are the numbers in front of the variables, negative 3 and 4. Group those together. This is multiplied, so negative 3 times 4 gives you negative 12. The x's, they have the same base, so group those together. X squared times x to the 5th. When multiplying like bases, keep the base, which is x, and add the exponents. 2 plus 5 gives you 7. This is multiplied together, so we can write it all together as one term. Negative 12 x to the 7th power. Vic number 2. Quotient of powers. Now quotient means the answer you get when you divide. So to divide powers with the same base, subtract their exponents. So this is the opposite of Vic number 1. I have 5 to the 7th divided by 5 to the 4th. 5 to the 7th means that there are 7 factors of 5. 5 is multiplied by itself 7 times. 5 to the 4th power means there are 4 factors of 5. Now, to divide, we subtract their exponents. But what's really happening is one of these 5's on top is canceling with one on the bottom. Match them up, and look and see what's left. You see that there are 3 5's as factors remaining. That's 5 times 5 times 5, which is 5 to the third power. Now the shortcut would be to subtract their exponents. They have the same base, keep the 5, and 7 minus 4 is 3. Example number 4. 4 to the 8th power divided by 4 to the 2nd power. So keep the base is 4, and subtract the exponents. Top subtract bottom. 8 minus 2 gives you 6. You can help remember this by saying, well, that big division bar is kind of like a huge minus sign for exponents, so 8 minus 2. There's your rule. 4 to the 6th power. You can say there are 4 factors of 6, multiply them all together, and you get 4,096. Example number 5. N to the 9th divided by n to the 4th. Again, keep the base, keep the n, and subtract the exponents. 9 minus 4 gives you 5. Example 6. This is one problem right here. Now I have several different bases. 2, 3, and 5 are all my bases in the top and in the bottom of the fraction. But I grouped them together, and you can see they're color-coded to make it a little bit easier for you to see. The 2's are going to go together. 2 to the 5th power divided by 2 to the 2nd power. They have the same base, so keep that base as 2. Subtract their exponents. 5 minus 2 gives you 3. These both have 3 as the base. Keep the base as 3 and subtract their exponents. 5 minus 4 is 1. The last set, 5 is the base. Keep the base as 5. Subtract their exponents. 2 minus, I don't see an exponent here, but don't forget that if you don't see it, it's a 1. So we say 2 minus 1 gives you a 1. Now, 3 to the 1st power is just 3, and 5 to the 1st power is just 5. So we have 2 to the 3rd, that's 2 times 2 times 2, which is 8. 8 times 3 is 24. 24 times 5 is 120. In algebraic form, it's a to the m power divided by a to the n power. Keep the base as a and subtract the exponents. Top subtract bottom. M minus n. Example number 7. Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is about 2 to the 7th miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? So this is a division kind of problem. We want to know how many times longer something is than something else. So Hawaii is bigger. It's going to go on top over New Hampshire. Well, Hawaii's shoreline was 2 to the 10th miles long, and New Hampshire's shoreline was 2 to the 7th. So this is a simple problem to solve because they have the same base, so keep the base, and it's division, so we're going to subtract our exponents. 10 minus 7 gives us 3. 2 to the 3rd power is 2 times 2 times 2, which is 8. So Hawaii's shoreline is about 8 times longer than New Hampshire.